Hello, hello, and welcome everyone. My name is Samira, and I'm delighted to be here with you today on behalf of Oxbridge X. So we specialize in preparing students for their 11 plus exams, helping them build their confidence and master the skills they need to excel. So with years of experience tutoring 11 plus students, I've helped countless children succeed in their entrance exams. And I'm excited today to guide you through some difficult 11 plus questions today, which will be encompassing maths and VR. This is the first in a series of regular live streams where I'll tackle some challenging questions, provide expert strategies, and answer your questions live. So throughout this stream, I'll pause and see if anyone has some questions, and hopefully it will be an engaging session. So if you're preparing for the 11 plus, or if you're a parent looking to support your child, you're in the right place. So I'm going to share my screen now. And like I said, in today's session, we'll be breaking down some tricky questions across the subtopics of maths for the 11 plus. I will stop to see if anyone has some questions throughout. So let me share my screen. Perfect. Right, hopefully everyone can see my screen. I'm going to make it bigger. So these questions that I've selected today have actually been handpicked from the 11 plus entrance exams. So I'll be walking through with you the strategies and methods and to be able to answer these questions effectively. So without further ado, the first question I have. Kiara needs 87 litres of water to fill her aquarium. Her bucket can carry 4 litres of water. How many times will Kiara need to fill up the bucket to completely fill up? So, to be able to answer this question, we need to find out how many 4s are in 87. And how did I come to that conclusion? Well, I know she has 87. I know she has 87 litres of water. Her bucket only carries 4 litres of water. How many times does she need? Will she need to fill up the bucket to completely fill up? So I know from that I've got 87 that I have buckets that can only carry 4 litres of water. So the calculation that is needed is division. So I'm going to go ahead and divide 87 by 4. So I'm not sure how everyone does division at school, but the most common method tends to be the bus stop method. So I'm going to ask myself, how many times does 8 go into 4? And that is twice, because 4 times 2 is 8. And next I'm going to ask myself, how many times does 7 go into 4? Well, it goes in once, because if I did 2 times 4, it's 8. It's too big. So essentially it only goes in once. However, 4 times 1 is 4. Now, it means that we have a remainder. We have a remainder of 3. So 87 divided by 4 is 21, remainder 3. Now, that can't be the answer. I'm definitely not done yet. It means that Kiara needs to fill her bucket 21 times, but we need to fill another bucket for the remaining 3 litres. So, rather than saying she needs 21 times to fill the bucket, I need to say it will take her 22 times to fill the bucket, because I have a remainder. Hopefully that makes sense. If anyone's got any questions, feel free to pop it in the chat box. I'll give you guys a moment to do so, but if not, I will carry on with the next question. Excellent, right. going on to the next question. So I've got a compound shape in front of me, and the question is, what is the volume of the following compound shapes in cube centimeters? Now, I think the first thing to ask ourselves is, well, what is a compound shape? So it's probably not the first time you've probably heard of the word compound shape, but if anyone knows what a compound shape is, feel free to put it in the chat. So I'll give you guys about 15 seconds or so if anyone could answer for me what a compound shape is. Right. So because you haven't got any answers, I will spoil it for you. So a compound shape is a shape made up of two or more basic shapes joined together. And what I mean by basic shape, I mean it can be sort of a square and a triangle, a rectangle and a triangle, and so forth, so forth. Now, it can be more than two shapes joined up together. It could be 3, 4 shapes joined together, and so forth. So now that we've covered what a compound shape, this is a compound shape because we've got two cubes, two cuboids essentially, on top of one another to make a compound shape. Yeah, which is often like an irregular shape, right? Because they're not the generic types of shapes that we know, like square, triangle, circle, etc. Now, volume. One of the key concepts that you need to know for the 11 plus exam is the formula of volume and the formula of area. In this case scenario, we need to know the formula of volume, which is, feel free, if you want as well, to jot it down in your notebooks. So volume is equal to length, I'm going to write L to make it easier, times by the width, so how wide something is, times by the height. Now, another key thing to notice is, whenever we give the answer to volume, it's not just centimeters. In fact, examiners would often mark you wrong for putting your answers just centimeters. The answer to volume is always centimeters cubed. With the 11 plus exam, you won't get the question right if you simply put centimeters. Same thing if I was doing area. If I simply put centimeters and I didn't put centimeters squared, I wouldn't get the mark. They will essentially penalize you for that. So, to find the volume of the shape, how am I going to approach this? Now, it doesn't matter how we do it, right? And I know that sounds crazy, but we will always arrive at the same volume at the end. But the easiest way to do this, I find, is by splitting the solid into two cuboids. And what I'm going to do is I'm going to split it horizontally. So I'm going to use this as one shape, and then the one at the bottom as one shape. And I'm going to call this shape A, and you can call this shape B. You can call it whatever you want, just to make it straightforward. So shape A. What is the volume of shape A? Let's use our formula, guys. So we've got length times width times height. Right. The length we've got 9. Excellent. Times by the width, which is, does anyone want to tell me in the chat before I carry on? All right, I'm going to spoil it for us. So the width of this one would be, guys, 6, because if you're looking down, that is sort of how wide it is. Excellent. And then times by, last but not least, if we look at the top, height, which is 3. Excellent. And I've got 9 times 3 times 6. Right. Let's write down what the B would be before we start to work out the calculations. So the bottom shape. Now, the width for that one would be 12, because as you can see from the bottom, it's 12 centimeters going wide. So, all right, 12 times by, what's the height? Well, you can see it's going up 3 centimeters. And lastly, the length we've got as 6. Now, remember what I said before. What you want to do is work out the volume for part A, shape A, and work out for the volume of B. And then, because it's a compound shape, what are we going to need to do? We're going to need to add it all together. So we can use long multiplication to do this. So using our multiplication times tables, we already know that 9 times 6 is 54. So all I've got to do next is 54 times 3. So I'm going to use the side to write out this calculation. So 54 times 3, 4 times 3 is 12. Carry the 1, and put the 2 down below. 3 times 5 is 15, plus the 1 is 16, 162. Now, I know we've got some smarty pants here, and I know we can do it in our head, but I always say it's better to double check and be right rather than being wrong. So when you've got these small calculations like 54 times 3, try to avoid doing it in your head, because the last thing you want to do, especially with 11 plus exam, is lose a mark because we thought we could do it in our head. So it's always good to just double check. The same thing here, 12 times 3 is 36. And then 36 times 6. Again, I can do it in my head, but because I don't want to get the answer, I just want to make sure, I'm going to write it out. So I've got 36 times by 6. Excellent. 6 times 6 is 36. Hopefully you guys have jotted that down as well. And then 6 times 3 is 18, plus the 3 is 21. Now, can I stop there? No. So I have found out the volume for part A, and I found out the volume for the bottom shape, which is B. Now what I need to do, like we said, is add it all together. So I'm essentially going to add the top and the bottom together to work out the volume of the whole shape. So 216 plus 162. 6 add 2 is 8. 6 add 1 is 7. And 2 add 1 is 3. So the volume is 378. Right. Has Samira finished there? Can she go on to the next question? No. Remember what I said before, you will get penalized if you don't put the correct units of measure. In this case, we've got volume, so it needs to be, remember we talked about it in the very beginning, centimeters cubed. Right. If anyone else was doing this question as I was explaining it and you got the answer right, make sure to give yourself a big tick. Right, let's go to the next question. Right, highest common factor. Now, does anyone know what the highest common factor means before I start off by explaining how to do this question? Anyone? I'm gonna give it 10 seconds, see if anyone puts anything in the chat. And if not, I can maybe spoil it for you guys. Right, so the highest common factor of 2 or more numbers is the largest number that can divide the numbers without any remainder. So I'll repeat that again. The highest common factor of 1 or 2 numbers is the largest number that can divide the numbers without any remainder. Now, let's keep that in mind and read this question here. So Alice has 30 roses and 18 lilies. She is arranging them into several identical bouquets. She wants each bouquet to have some ratio between the 2 types of flowers. What is the greatest number of bouquets that she can make? Now, in order to solve this problem, and this is the most common problem when you're doing 11 plus exams, and students often see this and they forget that in order to answer questions like these, for example, anytime the question says what's the greatest number of bouquets, what's the greatest number of cakes, etc., and you've got 2 or more quantities, the first thing our mind should be thinking of is highest common factor, right? It's quite subtle, and what that means is that you never really know that the method you need to do is highest common factor, but I've just given you a tip. Anytime the question says what is the greatest number of so forth, whatever it may be, and you've got 2 different objects or more, you need to think of highest common factor. Now, you may not know how to use common factor, so I'm going to explain in accordance to this question, but it might be that after this lesson you need to do a bit more practice on it. So the highest common factor between these two numbers, I'm going to write it out, 30 and 18. And what I need to essentially do is think of all the factors of 30 and think of all the factors of 18 and see what's common, right? It's pretty straightforward. So what are all the factors of 30? Let's think. So you've got 30 and 1. Maybe you guys can do it in your textbooks as well if anyone's writing along. 30 and 1, I've got 15 and 2. I've got 10 and 3. I'm actually going to draw a dash so that we don't get confused. There we go. 10 and 3. And I've got 6 and 0 and 5, don't I? Anything else? Not that I can think of. Right, 18. Right, do you guys want to have a go at writing down the factors of 18? And then I'm going to share it on the board. I'm going to give you 10 seconds to do so, because there's not that many factors of 18. Right, excellent. So I'm now going to spoil it for you guys. So you've got 18 and 1. I've got 9 and 2. 9 times 2 is 18. And I've got 6 and 3. Now, I'm going to do a dash so we don't get confused. Oh, put the dash in the wrong place. Please ignore that. 18 and 1, 19 and 2, and 6 and 3. Now, who remembers what I said in the start? The highest common factor is the largest number that can divide into both numbers in this case, because we only got two numbers, right? Without any remainder. What's the largest number that can divide into both 30 and 18 without any remainders? The best way to do that is what factor, right, is in both 30 and 18. I'll pause for you guys to have a look at the numbers you've got on either side and tell me what the largest number is. Largest. Right, I'm going to spoil it for you guys. The highest common factor between 30 and 18 is 6. So Alice can make 6 bouquets that have the same ratio between the two types of flowers. Hopefully that makes sense. So 5 roses for every 3 lilies. Hopefully that makes sense for you guys. Right. Like I said, that was highest common factor. Anytime you see a question, what's the greatest number between two different quantities, your mind should be thinking of highest common factor. Excellent. Right. Let's move on to the final topic for today. So I've got 3D nets and cubes. Now, this often probably needs a whole session on because it is quite a lot to take in. But I will try to explain it as thoroughly and as quickly as I can. And if you have, like I said, if you have any questions, there will be a time for questions at the end. So 3D nets and cubes, it is everyone's daunting nightmare when they're doing non-verbal reasoning. It's part of the component for non-verbal reasoning, and people often find it tricky. So I'm going to explain it the most straightforward way. So the 3 rules for 3D nets and cubes are duds, opposite, and orientation. Now you might be thinking, what on earth does she mean? Let me break it down. So a dud cube. When you've got a net of a cube, it often comes like this. And what the question will ask you is, what cube matches this net? Okay. Dud. A dud cube is a cube that the features are not shown on the net. Okay. They may show a shape or color that is not on the net. So for example, if I have a look here, this arrow shape is a dud. Why? Because if I look at the net that I have here, well, the 2 arrows are black. This one's grey. So that's a dud one. The way I think of dud is anything that's trying to trick us out. Anything, a shape that's trying to trick us out that it does not exist on the net is a dud. So I can automatically rule out duds, right? Same thing here. This one here, this cube here, this X shape, is it shown on the net? No, because it's trying to trick us out. So I'm going to rule that one out. That's what dud means. Right, opposites. The next thing I'm going to look for is opposites. So if we look here, right, we have this shape and this shape that are opposite each other. Now the rule is, right, anytime we have two opposite faces at the same time. So what I mean by that is, if I look here, I've got this sort of rectangle and this arrow. This rectangle and this arrow. Anytime that I have two shapes that are next to each other, that are opposite each other on the cube, it can't be, right? That cannot be an option. So if we look here, let me use my rubber so I can explain it properly. With this one, I've got the arrow and the arrow here on my cube, but where are they positioned on the net? They're positioned opposite each other. But remember the rule, anything that is opposite each other on the net cannot be next to each other on the cube. So anything that is opposite each other on our net, so this net here, cannot be next to each other in the cube. And now why is this one wrong? Well, what's wrong with it? Well, it's not the rectangle and the circle, because if you look at the rectangle and the circle, they're not really opposite each other, is it? No, the problem is with the circle, the two circles here that are next to each other, right? Touching each other, right? Hang on a second. Well, this one here and this one here are opposite each other. And the rule is two shapes that are next to each other on the cube can never be opposite each other on the net. Hopefully that makes sense. Yeah. And that's the second thing you think about. So you think about the dud, then I think about the opposite rule. And lastly, the one that everybody tends to find a little bit more difficult is the orientation rule. Now, the definition of orientation is the way that something is positioned. So now let's recap the net that we have here. This arrow is pointing towards, or you can call it a triangle. I'm going to call it an arrow. So this arrow is pointing towards this rectangle here. Now, what is wrong with that? If you have a look at the net, what's the arrow pointing to? Well, it's pointing to thin air here. And then here, what's it pointing to? Well, it's pointing to thin air. It's definitely not pointing to the rectangle. So that is wrong. The triangle should not be pointing towards this rectangle on the cube, because that's not what is reflected in the net, is it? Now, here, the rectangle here, it is pointing to the circle on the net. However, if you have a look here, look at the way it's positioned. I'm going to sort of tilt my head, right? Can anyone notice the way that it's positioned? It's positioned sort of horizontally in accordance to the circle. Whereas if we look here, it's actually pointing towards a circle. This is not pointing towards a circle. In this case scenario, this rectangle is pointing towards this arrow. Is it pointing towards the arrow in the net? No. So that is the orientation rule, right? The shape, okay, have to be pointed in the right direction. If it's pointing in a different direction, you can automatically, my favorite word that I like to use, especially when we're doing nonverbal reasoning, eliminate it out. Yeah. Nonverbal reasoning is all about using your rules that you know, right, and eliminating out. Okay. Now let's use this elimination process and the rules that we've just learned. We've got the dud, we've got the opposite and orientation, the DOO, and have a look at the first question on our right-hand side here. So here's my net. Okay. And my question was, which cube belongs to this net? So let's think of the dud rules, guys. Any duds? Also, feel free, if you like, to sort of answer these questions. Any duds? I'm going to give anyone a chance to write out. Are there any duds? Nope. Okay. So the next thing we're going to think of is any orientation. No, sorry, beg your pardon. Any opposite rules? I'm going to give you guys a chance to type anything that's wrong with opposites. Nope. Okay, let's have a look at it. So, does A break the opposite rule? Well, you've got a grey square here, and it's pointing towards this. Well, that's not opposite each other, so that's fine. You've got this one here, that's opposite here. Uh-oh, I seem to have found an opposite rule. Remember what I said, two shapes that are next to each other on the cube can never, ever be opposite each other on the net. So unfortunately, I've got to eliminate A. Right, anything wrong with B? Hang on, guys, something's gone wrong. What have we forgotten? Does anyone want to share what's wrong with B? Thinking of the dud, the opposite, or the orientation? What's wrong with it? And they give someone a chance to type anything in the chat. So, what is wrong with B is, why do we have two identical Zs? When in the net, I can't seem to see another identical Z. So, looking back to our rules, which one does that belong to? The dud rule. So, I'm going to cross out B, because the net does not have two identical faces. What they did, and they successfully did, is try to trick us out. So, I'm left with C and D. C, does C have anything wrong with it? Well, the dud rule doesn't apply. Okay. Does the opposite rule apply? No. So the grey square and the triangle, they're next to each other, that's fine. The grey square and this shape are sort of diagonally, that's fine. Triangle and this shape are next to each other. Okay, no opposite rule, that's fine. Okay, orientation rule. Let's think of this. So we've got this one and this one. The triangle, the bottom of the triangle, so the base of the triangle is facing the grey square. That's correct. That seems good. Yes. The triangle is next to this shape here. Let's tilt my head. Tilt your head. Right. That seems fine. Perfect. So nothing's wrong with C. But however, I'm gonna come back to it. Right. You can never be too short. So let's look at D. D. Right. I have this square, this grey square, next to this square. That's fine. The dud rule definitely doesn't apply for this one. I'm trying to look up the opposite rule, which you should be doing as well. The zigzag, the zigzag is next to this shape here, the sort of two black rectangles. What's wrong with that? The opposite rule. This shape and this shape is opposite each other. It cannot be next to each other on the cube. So by process of elimination, I'm left with C. Can you see how we've gone through each rule to find the correct answer? I didn't look at the net and go, oh my goodness, which cube is it? No. Everything is about strategy when you're doing nonverbal reasoning. If you've learned the rules, it's easier to do. Now, let's skip number 2, because I want to go into a more difficult one. I'm just being cautious of time as well. Let's go for the first one, A. Opposite, dud, opposite, and orientation. So, does the dud rule apply? Doesn't seem like it, because I've got all the shapes that are actually on the net, so that's fine. Does the opposite rule apply? Well, this shape and this shape. Uh-oh, guys, what applies? Does anyone want to put it into the chat quickly? Give me 5 seconds. So the opposite rule applies, because we've got this sort of irregular shape is opposite this blank square, right? But it's next to each other in the cube. That can't happen. By process of elimination, that one's gone. Right. Let's think. Dud rule, opposite, and orientation. Dud rule first. Have I got a dud here? Yes, I do. Because I've got two identical faces that, unfortunately, on the actual net, I can't see those are two identical faces. So I'm crossing out B. I don't even have to bother with opposite and orientation, because I already found something that's wrong with it. Yeah. So C. Anything wrong with C? Well, I've got this shape, and let's think with duds first. Nothing looks identical here, so I'm fine with dud. Let's go to opposite. Opposites, I've got this shape and this shape that are next to each other. That's fine, because it's not opposite each other. I've got this shape, and it's opposite, isn't it? So by process of elimination, I'm going to have to rule this one out because this face and this face is opposite each other on the net, and it cannot be next to each other in the cube. It just won't work if I folded it. So bye-bye C. Now, we know the answer is D, right? But let's just double check that dud opposite in orientation does not apply, right? So dud, have I got any duds? Nope, I'm all good to go. Have I got any opposites? Well, these two dots next to that, that's fine. These two dots next to that, right, doesn't apply. Orientation rules, is everything positioned correctly, I want to think. Yes, this is, yeah, absolutely, this is facing that, absolutely. This sort of squiggly lines, is it facing it something that it shouldn't be facing? No, looks absolutely correct. So that's our answer. Right, guys, hopefully that makes sense. I'm going to get back my mouse, hopefully, and finish off by asking, first of all, if you guys have any questions of anything that I went through. So let me go to the screen. So this is your chance, guys, to add any questions that you may have. Drop them in the chat, and I'll answer as many as I can. Also, it would be very helpful to know if you've ever struggled with anything else in 11+, because then that will give me and then I've just been told that the chat is disabled. Just going to wait and see if the chat works. Right. So I've been told our chat's not working, which is absolutely fine. Hopefully next time, guys, our chat should be working. You guys can ask all your wonderful questions. I hope that was very useful for you, going through nets and cubes, highest common factor, a division question, and volume. So hopefully you took some notes down and think about what you want to do next session. I hope you found the strategies very helpful. If you'd like to take preparation further, because there's only so much you can do in 30 minutes, right? Oxbridge is offering a free 11+ assessment for students. Now, the joy does not stop there, guys. We also provide one-to-one tuition, where after each lesson, parents receive a detailed summary. Students will get a quiz tailored to the topic that was covered. And then what we do is create a personalized learning plan to target key areas for improvement, leveraging sophisticated AI. To take the free assessment, let me show you my screen. Oops. Let's show my entire screen. Hang on. Hopefully you guys can see my screen. Yeah, perfect. To take the assessment, what you can do is scan this QR code. However, I do believe that it should be in the YouTube down below. So you can just go onto the website, take the assessment, and then what will happen is consequently we're going to get your results, and then you're free to book a trial session with one of our Oxbridge tutors. Hopefully it'll be me, and learn a bit more about 11+ there. Now, you're probably thinking, why Oxbridge? So this is more tailored for the parents. So Oxbridge X has experienced tutors from Oxford, Cambridge, and other Russell Group universities. What we do that differs from other tuition companies is that we offer you guys real-time feedback and assessments. We offer a personalized learning experience. And what that means is that, first things first, feedback is personalized, lesson plans are personalized. So lesson plans are according to the student's strengths and weaknesses, as well as questions, etc. They're all personalized. Homework is personalized to what the student needs to work on. And what we ensure is after every month, we conduct monthly progress tests to ensure that students are progressing. And lots of access and support. One thing that you probably need during 11+, which can be often a very lengthy process, is support. So our tutors are very flexible and tailored to you. And hopefully that gives you a chance to look into Oxbridge X and why it might be a perfect fit for you. Right. If anyone wants to answer questions, I've just been told that you can actually reload the YouTube page. So just refresh it. So go on and come back off again, and then the chat will work. So if anyone wants to try that, I will be here to try that. If you can't come back, please make sure to like this video. But I will give everyone a chance to go back and come back on again. So I'll just wait a moment to see if that works. What I will do in the meantime is put the QR code so that students can go ahead and try this assessment. So this assessment encompasses maths, NVR, and English. So it's a really good starter activity. You should also find it in the description of the live stream on YouTube. If you wish, you may also, for next week's session, well, hopefully the chat will be running a lot more smoothly, submit your tricky questions for us to go through next week through the contact form on the website. So if you go onto the website, oxbridge.com, you should be able to submit any tricky questions that you have on there. Perfect. So I can see that the chat is working. So if anyone's got any questions on any of the topics I went through, anything about Oxbridge X, please feel free to type on the chat, and I will answer your questions for the last 3 minutes or so. Right. So we're going to conclude there. For everyone that is tuning in, sorry about the chat. Hopefully it should be working next week much more smoothly. Like I said, please take the free assessment. I hope you enjoyed today's session. Submit tricky questions if you'd like to go through anything for next week. Okay. Please make sure to like this video, subscribe to the channel, and hit the notification button or bell so you don't miss our next session. And thank you so much for joining us. Hi, my name's been Samira, and I'll see you next time. It's been a pleasure. Thank you guys. Bye-bye.